Morning time, sir. Hi, Andrew. Good morning. Hello, Andrew. Hello, Andrew. Hello, Andrew. Hello, Andrew. Good morning.
Yes, sir. Morning.
Wow, I've been saying this about 5 or 6 times.
Oh no, I was away from the computer.
Oh,
Trying
okay,
to get some breakfast in as quick as possible.
okay. All right. I don't know where the other students are. I have a limitation today. I really can only spend about an hour with you guys today. So I was really hoping that you will come to class and come to class early. It is a challenge that I have in this school. So what we're going to be doing, is, since you're here and it's my limitation, let me just, oopsie. You were here last week, right?
Yes, sir.
And I did solving exponential equations.
Hold on, sir. Let me get this. Sir,
Yes,
I'm back.
all right. Okay, so last class, this is what we did this last class, just confirming it here.
Exponential.
Is that familiar?
Yes, sir. But if I think we did this in the last section of the class, sir.
Mm-hmm. So
And
I am now reviewing that last section.
okay, sir.
So how are you with it? Are you understanding it? What? All right. So no problem. Let me go through again.
I had zone out in the last part of the class, sir, because tiredness got the best of me. So I knocked out of the last part.
Okay.
Okay. This section. But I did this before, sir. So I should be able to remember exactly what it is. Exactly.
All right. Okay. Let us let us see what is happening. Let us see what is happening. So I gave you the question: 2 to the 2x plus 3 times 2 to the x minus 4 is equal to 0. And we are asked to solve that equation. Now, the only way we can solve that equation is by substitution. So we can only solve this equation by substitution. Therefore, we need to make a substitution for 2 to the x, and this will result in a quadratic equation in y. Why do we need to make a substitution of 2 to the x? The simple rule is look for the smaller of the two indices and to make it y. Look for the smaller of the two indices and make it. So what do you mean by smaller of the two indices? Look, 2 to the 2x and 2 to the x. Which of these two? This one or this one? Look smaller. 2 to the x, not 2x, 2 to the x. 2x is different from 2 to the x. It's 2 to the x, yes. So therefore, we're going to let y be equals to 2 to the x. We're going to let y be equals to 2 raised to the x power. We're letting y be equals to 2 raised to the x power. We're letting y equals to 2 raised to the x power. Now, when y is equals to 2 to the x power, you would recognize that, come on, we are only able to make a substitution for this, 2 to the x. We still don't have a substitution for this one yet. And we can't introduce another variable into the function because I can't solve an equation. And the word "and" suggests one equation with one unknown, with two unknowns. So it means that I have to make a substitution for the 2 to the 2x. How can I move from y equals 2 to the x to 2 to the 2x? It means that if I square y, it means that if I square y equals 2 to the x, this is what I'm going to get. If I square y, that's what I'm going to get. So when I square my y, look at what happens. Y squared is going to be equals to 2 to the x squared. And recall, what I want you to recall, a to the m raised to the nth power is going to be equals to a to the mn. A to the m raised to the nth power is going to be equals to a to the mn. A base that is raised to a power that is in turn raised to another power, we are going to be multiplying the powers. So a to the m raised to the nth power is going to be equal to a to the mn. All right? Now, so therefore, this y squared is now going to be equals to x times 2 is 2x, 2 to the 2x. So that's what y squared is equals to. Y squared is going to be equals to 2 to the 2x. So we're going to be looking now at the question to see if we are seeing a 2 to the 2x. Yeah, there you go. So this is 2 to the 2x. So this is now going to become y squared. So therefore, we have a substitution for 2 to the 2x and 2 to the x. So what I'm doing, I'm recalling the question that was given. I'm recalling this question. This is a question that was given, and I'm now making the substitution. So 2 to the 2x, see here, 2 to the 2x, I'm going to substitute it as y squared. See right here, so y squared. And 2 raised to the x power, I'm going to substitute this as y. So this becomes plus 3y. See here, plus 3y. And this minus 4 is here. So I now have my quadratic equation. I'm going to pause here for a minute and take any questions so far. Any questions? Any questions? Will someone answer me, please? Not going through this thing.
Oh, sir, I said no, sir. I'm good.
Oh, no, you said no, but you're muted, so I wouldn't hear you because I'm watching the
Sorry,
participants
sir.
list. All right, cool. Thanks, Cheche. All right, so so now when I reach right here, I'm going to factorize. Oopsie daisy. Some of you may forget how to factorize, even though we did it up to recently. So what I'm going to do is I'm going to refresh your memory. Oops. I'm going to refresh your memory. I'm going to refresh your memory. Remember now, we're multiplying the coefficient of y squared by the constant. We are multiplying the coefficient of y squared by the constant. Multiplying the coefficient of y squared by the constant. Coefficient of y squared by the constant. Now, the coefficient of y squared is, that's a question. The coefficient of y squared is?
So the coefficient of y squared is a constant.
The coefficient of y squared. What is the coefficient of y squared? That's what I'm asking. Tell me the coefficient of y squared.
1.
Very good. So the coefficient of y squared is going to be 1. Coefficient of y squared is going to be 1. The coefficient of y squared is going to be 1. And look at what we're doing. I'm going to just help you here too. All right, so I'm helping you here to do the factorization. So recall, multiply the coefficient, that is Andrew. It is a number in front of. So when you hear coefficient, it's a number in front. All right, the number in front of, right? So we're going to multiply the coefficient, which is a number in front of y squared, by the constant, and the constant is that one, is the one that stands alone. So the -4 is the one that stands alone. The one that stands alone is a -4. So that's what it is that we're going to have. And that is, I'm multiplying the coefficient of y squared, it is 1. Let me just put that there. Let me put that there. The coefficient of y squared is 1. Let me put that in blue. Coefficient of y squared is 1. And I'm multiplying that 1 by the constant 4. I'm going to put the 4 also in blue. Right, sir? So that when I'm showing you here, is that I'm multiplying that 1 by that -4 to give me -4. To give me -4. So when I multiply this 1 by this -4, look, the coefficient of y squared, the number in front of y squared by the constant, 1 times -4, see to yourself, is -4. Then now we need two numbers. when multiplied together gives -4, but when added gives +3. Where that +3 come from, sir? That +3 is the 3 in the middle. And I'm color coding, so it is that you can see the +3 is a 3 in the middle. So now the factors are +4 and -1. The factors are +4 and -1. So when you have +4 and -1, when you have +4 and -1, we're going to make a substitution into the equation for the value 3. And more specifically, the value 3y. So let me just make a notation here. So the factors are following. And we therefore replace the middle with, I'm doing this so that you can understand what I'm separating with +4y and the -1y. That's what we're doing, right? I'm replacing the middle term 3 with +4y. So where the 4 come from and the 1 come from? See here, those are the factors. Oh, I see, sir. So all we did really is just put the y to it. Yes. So you can tell me why I put the y to it again? You answer me. Why did I attach a y to these two? Tell me.
Because we use the coefficient to multiply the constant, which is a 4.
Yes, but
And the code,
fair enough.
y.
Yeah, tell me why I put the y. Tell me why I put the y now.
The y is squared.
Tell me why I put the y. So what the first part was okay, but tell me why I put the y now. Tell me why I put the y. Originally I had 4, +4 and -1. Why did I put the y? Okay, so Andrew, answer me. Somebody try answer me, please.
I think, sir.
Morning.
Morning, who's that Lord? That's not even away from me at all. But she was here before, Miss Danny. What is going on?
Sir, I have a little cold and my
Oh no,
know
what are you doing?
Sir?
What are you doing about it?
I took some medicine last night. It actually started last night, so I don't know.
Okay, very good when you catch it early.
Yes.
Do me a favor. I know it's not the corona, but at this time, try not to get you a cold. If you, and this goes for anybody else in the class. The moment you feel like it's coming on, fight it. It's very
Yes,
important. Oh Lord, you don't have a fever with it?
Please, sir?
You don't have a fever with it?
No, sir. No, sir.
Okay, all right. Just see if we can fight it and try to keep as best as possible and watch it very closely. All right?
Yes, sir, I am.
All right, cool. All right, so I was asking a question though. right, so I was asking a question. Why did I attach a y here? And why did I attach a y right here? Why did I attach those y's? I said to you that the factors are -4 and +4 and -1. Why did I attach a y? I just want to see if you guys are thinking. It's not difficult.
Sir, because the -4, the +4 and the -1, sir, they would add up to the 3 and the 3 has a y.
Very good. Thank you very much. So remember,
You have to attach the y to the numbers.
Thank you very much, Miss Dum. So this is exactly why I'm attaching a y, because of this y. So when I do my substitution right here, +4y minus 1y, I will get this 3y. Oh, sir. So you're therefore saying then that if this were 3a, that means you'd attach an a to the 4 and an a to the -1? Absolutely. So any variable we are working in, we will attach the variable to the factors so that it fits into the equation. All right? And it's important. It's very important. Very, very important. Okay. So now I'm going to make the substitution. And I'm going to say, so it's what I'm doing here. I'm working with this now. I'm working with this, but I'm making a substitution for 3y. So I'm going to say 1y squared plus 4y minus 1y. This I put in here to replace the 3. And then I write back the -4 equals 0. And then I'm going to be grouping now. So when I group, I'm going to put the first 2 in one bracket, and then the other 2 in the other bracket, leaving out the middle sign. Let me just put a notation here. Remember that the first 2 will be in PARENTHESES, leaving out the middle sign, and finally placing oh, come on, Mr. Shine. PLAC, placing the last 2 terms in PARENTHESES in parentheses, right? So I said, remember that the first 2 will be in parentheses, leaving out the middle sign, and finally placing the last 2 terms in another parentheses. All right, so it's very important that you remember that, and I will highlight something because I want you to see something here. It's very important that you see something here. Leaving out the middle sign. It's very important. And then I'm going to tell you a story when the middle sign is left out. It's very important, right? Very, very, very important. You have to leave out the middle sign. Very important, right? So let's go back. So now, y squared and 4y in the first set of parentheses, leave out the middle sign, and then I'm going to put the last 2 in the parentheses. All right? Watch me now. I'm going to tell you a story. Once upon a time, once the middle term or the middle sign is negative, then flip the last sign in the brackets. No, so we can't have the brackets, and now we use big word P-A-R-E-N-T-H-E-S-E-S in the parentheses. The end. The end.
Sir, go again. Sir, what's
Alright.
the, sir, go again with that one.
All right. So I'm saying once the middle sign is negative, and let me just unbold this and then bold the middle sign. So that the middle sign is consistent across. So once I'm saying to you, once the middle sign is negative, see here, like the one here. Once the middle sign is negative, like the one here. Then flip the last sign in the parentheses. See here, the last sign in the parentheses, again, flip it. What do I mean by flip? If it is positive, you turn it to negative. If it's negative, again, turn it to positive. Again, flip the sign. Now, if the middle sign is positive, left it alone. Watch me now. Watch me now. You notice that this was a negative 4 right here, so? And it seemed like it turned to a positive 4 right here, so? That's what I'm talking about. The sign flipping here. Look why. Because this negative sign, when multiplied by this negative sign, gives with this positive sign. Remember, when you multiply two negative numbers, you get a positive number. Reason. When you multiply negative numbers, the result is positive. That's the reason. That's the reason. Even if there are two negative numbers, the result is positive. So, so remember now, the reason is going to be when you multiply two negative numbers, the result is going to be positive. The result is going to be positive. All right? So now that we understand why it is that this sign here is flipped, and this only happens when this middle sign is negative. If the middle sign is positive, left it alone. Left the last sign in the parentheses alone. All right? And why we flip it? Because when you multiply two negative numbers, you get a positive number. For consistency, let me put the reason for this up here, and then say to you, if the middle sign is positive, leave it alone. All right? Now, so let's continue. Let's continue now. Oh, and besides, remember, whatsoever sign is in this
Right,
bracket.
sir. Sorry to cut you, but I'm just trying to paraphrase to see if I get what you're saying. See, so once the middle sign is negative, the other sign in the parentheses is positive, and once the middle sign is positive, the other sign in the parentheses is negative. That's what you're saying?
No. What I'm saying to you is, once the middle sign, this middle sign is negative, the last sign in the parentheses is going to be flipped.
Yeah.
But if the middle sign is positive, you're not flipping anything.
Okay.
That's what I mean by left it alone.
All right.
So let me say it one more time. So if the middle sign is negative, the last sign in the parentheses is going to be flipped. If the middle sign separating the two brackets is positive, you're not flipping anything. You're only going to flip if it is negative. Otherwise, you're not flipping. Got me?
Yes, sir.
Okay, good, thanks. and then, look at what is going to happen. Oh, and I was saying to you, also remember that the sign that is right here in this parentheses, the last parentheses separating these two terms, must be the same color sign in this parentheses separating that. But I mean that color, sir. If it is a positive sign here, so this has to be a positive sign here. So if this is a negative sign here, so this has to be a negative sign. So the two signs in the brackets must be the same. If they are not the same, you can't use factorization by grouping. And you see, is it we're using grouping to give? That means we're using factorization by grouping. All right. So let's continue. We did this last week, but I'm just reviewing so that you guys can have it, because I'm going to have you guys work on a question or two for me. So let's go. So now I'm factorizing. What is common here that is common there? Answer. What is common between y squared and y? 4y.
Y.
Y. Very good. And I'm taking out the y. Very good. And I'm taking out the y. See the y here that I'm taking out? What is left? When I take out one of the y's from this y squared, I'm going to have y left. Tell me if you agree.
Yes, sir.
I'm going to take out the y from this 4y. I'm going to have 4 left, don't?
Yes, sir.
Good. So I'm going to have y times y plus 4. And then, oh Lord, what is common between 1 and 4? Remember, 1 is a factor of anything. So if you're not seeing something seemingly, it's going to be a 1. It's going to be a 1. So I'm factoring out a 1. See here? This one that is outside, I'm factoring out the 1. And when I factor out the 1, I'm going to have y plus 4 in the other parentheses. Y plus 4 in the other parentheses. Now look at this story. You recognize that this y plus 4 is the same thing as a y plus 4?
Yes, sir.
I can then factor out the y plus 4. See it here? I'm factoring out the y plus 4. And when I factor out the y plus 4, watch me. When I take out this, what is left on this side?
Y, sir.
Y, very good. And see the y right here, so that y. And when I take out this, what is left on the others? What is left when I take out this y plus 4 on this side?
-1.
And this is why the negative 1 is right here. And then I put my man equal to 0. So what I'm doing is actually reducing this line into this line. And I can now say either, y plus 4 is equal to 0, because one of these must be equal to 0 for this to be equal to 0, because 0 times anything is 0. So it's either this equals to 0, or this equals to 0, or the two of them equals 0, in order for this to be equal to 0. So we're going to find the value of y that makes this portion equal 0, and we're also going to find the value of y that makes this portion equal to 0. Because either the one here, or the one here, or the two of them. Or the two of them. So let's go. We're going to say y plus 4 equals 0. And then we're solving for y. So we're going to add -4 to both sides to eliminate this 4 here. So when we do that, those 4s will be eliminated. So I'm going to have 0 minus 4.
So it's -4 from both sides.
Now I'm adding 4 to both sides. -4 to both sides. I'm adding -4. So I'm adding the additive inverse. So I'm going to be using the additive inverse in order to cancel this -4. And let me tell you why. When you're going to little school, your teacher would say to you, take this +4 over to the equal sign, it becomes -4. Nothing no go so. All right? But sir, if you take this +4 over the equal sign, you know have y equals -4. But sir, see how the y equals -4, so how you not go so? That's an incorrect way of looking at it. You can't take up this, +4 and put over the equal sign, let me see. We can't take it out because this +4 upon paper. And you can't take it off of the paper and put over here yourself negative 4. So what it is that you're doing mathematically in order to get rid of this positive 4 on this side is to use the additive inverse. So what do you mean by inverse? When you use the additive inverse, it means that it cancels out. The additive inverse means that it cancels out. So this positive 4 will be cancelled if I were to add a negative 4 to it. See it right here, so? The positive 4 is cancelled if I add a negative 4 to it. But because it's an equation, what I do with one side of the equation, I must do to the other side. So since I'm adding a negative 4 to this side of the equation, I must add a negative 4 to this side of the equation also. Because if I don't do it to this side, it means that I'm changing what it is that I have. And I can't. So now that this positive 4 cancels with this negative 4, I'm going to be left with 0 minus 4 on this side, which is just equal to negative 4. And I'll do the same for here. So y is going to be equal to positive 1. So I have solved the equation. I have solved this equation. Where's the equation? I have solved this equation in y to give me negative 4 and positive 1. But remember, see as I put it here, so either y equals negative 4, either y equals negative 4 or positive 1 from up here. But recall, we weren't the ones who introduced y into the question. Therefore, we need to remove it. The original question did not give us y in it. We were the ones who introduced y to the question. We were the ones who introduced it. So we have to remove it. So how are we going to remove it? By resubstituting. So recall that y is equal to 2 to the x from up top. We made y to be equal to 2 to the x. And if we are getting a value of y to be negative 4 and a value of y to be positive 1, we are going to substitute this negative 4 for y and this positive 1 also for y, so that we can find the values of x, which is what the question asks us to do. We can find the values of x. So now we're making a substitution. Negative 4 is going to be equal to 2 raised to the x power. Negative 4 is going to be equal to 2 raised to the x power. Or negative or positive 1. This positive 1 is going to be equal to 2 raised to the x power. Not 2x, you know. It's 2 raised to the x power. Remember, it's exponential. Remember, it's exponential. All right? Indices. So it could be exponential or indicial, equations. So it's exponential. So look at what we have. So having made a substitution, oh Lord, we know how to solve these questions. These are called simple exponential equations. Recall, note that these are simple exponent, simple exponential equations done in a previous in a previous lesson. So you have to note, and this is why it's important, is when you miss class, you have to catch the something, because I'm building on what it is that we would have done. So I couldn't have started this topic without first showing you how to solve simple exponential equations. Sir, I can't remember us doing simple exponential equations. All right, no problem. I will just refresh your memory. Oh, these is talking about, sir. Absolutely. These are what we're talking about, right? So these are our simple exponential equations, right? Those are our exponential equations, all right? And they would start from up here. See, 5 to the x equal 10. Those are our simple exponential equations, all right? And we would have done those. We spent quite a bit of time in class one Saturday morning to just go through all those questions, and you guys did pretty well in answering them. So remember, those are our simple exponential questions done in a previous lesson, all right? So now what you need to recognize is that, matter of fact, I want you to go ahead and solve these two simple equations for me. Let me see if you remember. I'm going to ask you for 2 minutes. I'm giving you 2 minutes to go and do those. I'm going to come up with an announcement. Okay, so let me hear what you got for your answer for -4 equals 2 to the x. Anybody got an answer for this one?
Here 2.
You got an answer with this one here to be 2?
Yeah, yes, I'm not sure.
Okay.
There, I didn't get one.
You didn't get what?
I didn't get an answer.
Okay, what you got, Elizabeth?
Sir, my stuck.
You stuck?
Yeah,
What do you mean by stuck? The calculator stuck or is just you stuck?
me stuck.
Okay, what you got for the answer for this one?
Never attempt it, I'm stuck. I
You know
wonder
what?
if I foolish me I do.
You must approach your questions with confidence. Did anybody do this one? 1 is equal to 2 to the x?
Yes, sir.
What you got for this answer?
0, sir.
You got 0? All right, so let's go. And that's the aim, you know. And that's the aim, you know, guys. I am not interested in a correct answer at this stage of the game, you know. Absolutely not. I do not care for a correct answer. So I'm not going to say, Elizabeth, you're wrong. Neither will I say, Donnie, you're wrong. How could you get the questions wrong? That's not my aim. My aim is that you give an attempt. And then no, my responsibility no, is to go and say, all right, this is what it is that you did or didn't do. Let's go. So there are no real values of x that will satisfy 2 to the x equals -4. There are no real values. What does this mean, sir? You cannot take the logarithm of a negative number. You cannot take the logarithm of a negative number. There are no real values. So therefore, we are going to say we have no solution for that value of x. We have absolutely no solution for that value of x. No solution. Go ahead, Elizabeth.
So what about the exponential form? You said if we check something about right side and left side, and if we can't put it in log, if we can't change it out in logarithm, we must use the exponential one.
Very good. Okay, so can you change -4 into an exponential form? Answer me done. I'm happy that you remember what I said, you know, because I remember what I said. So you tell me now, can I change -4 into an exponential form?
Sir, no, sir.
No, man. Tell me why no, man, because you get warmer and warmer and warmer. So I love the answer no. So tell me why no, done.
Sir, because it's negative.
Excellent. 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 Because you cannot write -4 as an exponential form. There is no way. Me want to say, who can do that? Can't do it. Can't do it. So we have no solution. We have absolutely no solution for that form. All right. So what we're going to have is just 2 to the x equals 1. What we're going to have is 2 to the x equals 1. And let me just do this. We're going to have 2 to the x equals 1. And then recall, I'm not going through this again, you know. I want you to look at this and tell me if you agree with me right here, because this is the simple exponential equations that we solved last week, week before, thereabout. Look at it and tell me. Tell me yes, tell me no, tell me yes, tell me no, tell me yes, tell me no.
So yes, no, about what, sir?
That you understand this piece.
Oh, yeah.
Nice.
Yes,
So our
sir.
x is going to be equal to 0. So the value of x is, so we have just one value of x. Now, alternatively, I did this method, we call it again, the industrial method. And remember last week, I gave you something last week to say, I gave you a summary last week, I'm remembering this. Once both sides of the equation can be written in the same base, then we can either use indices or logarithms to solve the equation. If on the other hand, only one side can be written to a base, then you must use logarithms to evaluate the question. So it comes back here, the same summary comes back right here. So you're going to say to me, but sir, 2 to the x equals 1. I can't write this 1 in the same base as 2. Yeah, man. Remember, anything raised to the power 0 is 1. Remember, anything raised to the power 0 is 1. So what I'm going to be doing is to convert this one as 2 to the 0. You know, sir, I'm seeing something now. That means if you had 3 to the x equals 1, you could write this as 3 to the 0. And if you had 10 to the x equals 1, you could write this as 10 to the 0. Absolutely. Because you're now converting this one into the same base as this one. So you can use indices. So then, since the bases are the same, I can equate my powers. And I get my x equals 0 just as this x equals 0 up here. All right? All right. So having gone through that, I'm going to give you just one to do for classwork today. And just to say to you that, as I told Andrew was here with me for about 15 minutes at the start of the class. I have an engagement that I must leave you in another 21 minutes thereabout. You don't need to be worried. We will be able to make up this lost time. Matter of fact, we have been doing very well. Tajay, you may need to keep in touch with me, Papa. So any difficulties you have in Tajay, you must touch base with Sir, so that Sir can do some stuff with you. Tajay is the only one that would have joined pretty much after, you know. So Tajay and I are working on a trajectory in terms of him going through the stuff. Yes, please.
To be honest, sir, most of the question, you know, me can't answer. I just shock. And did I understand everything where you do, sir? And how you arrive at the answer, but me just shock when I see the question.
And guess what? It is a fear that you have, and you have to go work through that fear. So this is what, you know what I did a while ago, Dani? This very example that I just went through, I went through last class, towards the end of last class. Yes, and I started it at the start of today's class, because I am aware. Let me tell you, I'm not speaking about you in particular, Dani, but one of the things that I recognize is that there are some of you in the class, the last time you opened your Precalculus book was last week Saturday morning. Today's the first time since last week Saturday the Precalculus book is again opened. So what needs to happen is that you have to conquer that fear that you may have and work the question. So done, you don't need to worry about how the question looks ugly. Follow what Sir says. What Sir says, you're going to get the exponential equations. You're going to look for the smaller of the two in the exponent, and you're going to make it y. Then you're going to make y squared. You don't have to make it y. You can make it any. You can make it u. You can make it v. But you know, for the sake of this question, you can make it y. Then you're going to make the substitution. When you make the substitution, then you're going to end up with a quadratic equation. None of you here can tell me, so you don't know to solve a quadratic equation, because that was CXC maths, our foundation concept 1, 2, and 3. So when you solve this quadratic equation, then you're going to get the values of the substituted unknown. Then you have to resubstitute. And when you resubstitute, you're going to end up with a simpler exponential equation. that you already know how to solve. And then that will be the end of the question. So, so if you, hold on a minute, please. So just remember, so just remember, let me see if I can do something here. Oh Lord, where am I? So one, you're going to make a substitution for the smaller SMA, for the smaller of the two exponent exponent, 2 2, you're going to use this to evaluate EVALU, the other exponent exponent, and it's supposed to be exponents.
Okay, so the smaller value would be 2, right?
2 to the x. Remember I said exponent, you know, so it's not 2.
Oh, yeah.
The x moment to be 2 to the x, right? So the smaller one is going to be 2 to the x, and then the bigger one is going to be 2 to the 2x. So use this substitution, SUBSTITUT, use this substitution to generate GENERATE, quadratic equation, QUADRATIC, Then 4, you're going to solve the quadratic equation. Solve the QUADRATIC. You're going to solve the quadratic equation. Then 5.
Question on your finish, sir.
No problem. So when you solve the quadratic equation, you are going to resubstitute You're going to resubstitute the values for one above. This one above, for the smaller of the two exponents, to get smaller or simpler exponential 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 equations. In 6, solve. Okay. Solve is exponential equations, because it's more than one is supposed to get solved. Solve the exponential equations. When you go through this, tell me if you are seeing anything that I would have missed, and will be more than happy to make the adjustment. So let us just go through this before Andrew asks his question. So 1, you're going to make a substitution for the small of the two exponents. All right. Then you're going to use this to evaluate a substitution for the other exponent. SUBSTITUT, a substitution for the other exponent. Substitute substitute is substitution. That let me just say, substitute these into the original original equation to generate a quadratic equation. To generate a quadratic equation. And then we're going to solve this quadratic equation. And then we're going to resubstitute the values for one above to get simpler exponential equations. Then we're going to solve this exponential equation and then to arrive at your answers. To arrive, A-R-R-I-V-E, at your answers. Go ahead, Andrew.
So we know calculations and maths have a way of flipping the script on the student. So just want to know, is there always going to be a bigger and a smaller exponent?
Yes, sir. Let us look. Very good. Let us look. Look at number 5. You see a small and a bigger here?
Yes, sir.
A small and a bigger?
Yes, sir.
A smaller and a bigger. You notice I skipped 2 a while ago, right? I skipped 2 and 3.
Yes, sir. Got them look.
Smaller and a bigger, don't?
Yes, sir.
Smaller and bigger. I'm skipping number 10 because we're going to come back to that. Smaller and bigger, smaller and bigger, smaller and I'm skipping number 13. Smaller and bigger, smaller and bigger. Yes, you'll have smaller and bigger all the time. But this level, you can get something else at another level. Let us look at number 2. You will say, but sir, this is smaller and bigger, because I am not seeing, I was expecting to see 3 to the 2x. But no, sir, I'm seeing 3 to the 2x plus 1. Sir, what go on with this? It's not a problem. Let me just show you what that is. Not a problem for that one. You see where you see the 2x plus 1? You are going to break it up into 3 to the 2x times 3 to the first. So this term here is going to be broken up into this term here. Sir, why did you break it up? And how did you break it up? It was broken up because, remember, when you're multiplying and the bases are the same, you add your indices, you add your exponents, you add your powers. So this 3 to the 2x plus 1 was really written to confuse you. And it's only the astute student will recognize, oh, this is the same thing as 3 to the 2x times 3 to the first power. 3 to the 2x times 3 to the first power. So when you do your substitution, you're going to end up with, this is going to be y squared. So we end up with 3y squared minus 26y minus 9, which is this quadratic equation. But really and truly, this is the same, smaller and bigger. But it's just that this bigger one here, you have to break it up first. This is what I'm talking about. So this is one example of the bigger one you have to break up first. This is another example of the bigger one that you have to break up first. So really and truly is a smaller and the bigger. Let us look at 10. This is 6.3. No, this is 6 times 3 to the 2x. And this is 13 times. Remember, in big school, them something I mean times. All right. So yes, Andrew, for this level, it is always going to be a smaller and a bigger. You don't have to worry about that. It's going to be a smaller and a bigger. All right. Okay. So this is what is going to happen, guys. As I said to you, I have to leave by 9:30. What I'm going to have you do for me is to work number 1. It's the work number 1 in these 9 minutes. Just make an attempt of it. Go ahead, please.
Sir, before you leave, sir, you can send this off to us.
Absolutely.
While we're doing the question, yeah,
No. Okay, fair enough. Since I'm not going to make any adjustment, no, I don't want to send it off. I'm going to tell you why. Because I have a solution right here. So I want to see what it is that you have done first before I send the solution. It will defeat the purpose.
Sir, so.
But I will send it immediately after I get the class in, so you can see what is happening. So what I'm going to do, I'm going to project the workout to the question before, which is this, so that we can follow now to work the question that I just gave.
Yes, sir, that is what I really want.
Right. So start working for me, please. Thank you. How is it going?
Yeah, it works.
I'm going to switch this thing here 1 minute.
Serenity procedure and say that you may have.
That's it, right?
Yes, sir.
The silence is deafening. Obviously,
Mhm.
mhm. Mostly. Hello, somebody. Come on. Guys, you're not answering my asking a question, no? Just let me know where you are.
Sir, but upon the, all right, for the first y when we work out, we get y equal 1. And my work out the second y right now.
Okay, all right. Let me help you out because I'm going to run in a few. So let me just hold out. What am I doing? No man, y is not equal to 1, no, y is equal to 2.5. Let me. So we're going to have, this is a question that we have. Let me just double check to see if it's the same question. Yep. That's a question that we have. And we're looking at the small of the 2, so we're going to let y be equal to 2 to the x. And then we square y, we're going to end up with y equals 2 to the 2x. Then we're going to make the substitution. 2 times y squared minus 5 times y plus 2. 2y squared minus 5y plus 2. Then we factorize this. Multiply the coefficient of y squared by the constant. 2 times 2 is 4. And the two numbers when multiplied together will give me positive 4. But when added will give me negative 5. That will be negative 4 and negative 1. See here? Negative 4 and negative 1. So you notice I don't have the whole heap of narratives in this part of the question, because when you're doing the question for me, you're not going to have them right up. I only did a right up in this question. The whole heap of right up because I want to explain what I'm doing. But now that you are doing it, you notice you don't have the right up. You just need to know. Go ahead.
On the question, is that 2 raised to the power of 1? Why?
Yeah, I just show you that it's 2 raised to the power of 1.
Oh,
no, you don't have to put it there. No, you don't have to put it
Oh.
there. No, I'm just showing that when you say a number, it is really raised to the power of 1. So you don't have to worry about that one.
Oh.
And then when I factorize the group, I'm going to have, by grouping, I'm going to get the first 2 in a bracket, the second 2 in a bracket, leave out the middle sign. When the middle sign is left out, we can flip the last sign. See, this was plus 2 up here, so it becomes negative 2. Dani, are you still here?
Yes, sir.
Okay, good. You see what I was talking about a while ago here?
Yes, sir. Whenever I do that, still I'm never flip the sign.
Come on, you have to. You must. I'm going to send this off in another couple of minutes, and I'm just trying to just go through this. Yes, please.
Well, sir, but if you negative 4 and negative 1, they will give you a positive 5. You get what I'm saying, sir? They won't give you a negative 5. They won't give you a negative 5y. Negative 4y and negative 1y will give you a positive 5y.
Really? When you're adding 2 negative numbers, you get a negative number. So minus 4 minus, yeah, minus 4 minus 1 is minus 5. But when you multiply these 2 negative numbers, you get a positive number, which is what you want. So these are the. All right, and then now I'm going to say what is common here, that is common there is going to be 2y. What is left is going to be y minus 2. Matter of fact, you see when I flip the sign right here, you recognize that the same sign that is here is the same sign that is here. I can't have 2 different signs. Or it's a question can't be solved using factorization by grouping. And I've used another method. All right? And then what is common between y and negative 2 is going to be 1. And now I ask myself what is common here, that is common there. And it's going to be 2y. It's going to be y minus 2, sorry. Y minus 2. And what is left when I take off y minus 2? 2y. See it here? Y minus 2, what is left? Minus y. See it here? So either 2y minus 1 equals 0, which gives me y equals a half. You notice I don't put that step there. I don't write that step because I expect you to know that. But you can fill in the blanks. So what do you mean? In this step up here, when I said either this is equal to that, and then I show you all of here, I just moved from here down to here, right? This here example here was also introduced to what it is that we're doing. I now expect you to move on, all right? And where am I? Question 1. And then we do all of that, we can get x is equal to a half. Now, I will say to you, don't put 0.5. Keep it as a fraction because this 1/2 is the same thing as 2 raised to the -1. See it here, so? And now the bases are the same. So I can equate the powers and get x equals -1. So I get x equals -1 right here. And this 2 will be 2 to the x equals 2. And as Andrew, I put up here, 2 is the same thing as 2 to the first. So this is 2 to the first. So there's a 1 up here. The bases are the same, so x going to equals to 1. And that's the end of the question. And of course, you can use logarithms. I just use the logarithms here to show you that you can use either of the 2 methods. And then that will be the second example. All right, I'll take your questions and then we end off and I will, let me just, I'll take your questions. Are there any questions?
Not relating to this, but the recording, sir. I appreciate that if you could send it for the class.
All right, I'm gonna ask someone to just repost the YouTube channel so that you can log on to the YouTube channel to get the recordings. All the recordings are there from day one, yeah, man.
Okay, so because I know it's with the Google Drive, it's like they're saying that I don't have access to it, or I have to request access or something like that. When
No, man. Oh no, man. When you click on the YouTube channel, you'll get the recordings right there and then. Matter of fact, let me not even say, is there anybody having a challenge accessing the recordings from my YouTube channel? Sorry, maybe I need to ask a question another way. How many of you have been accessing the information, the recordings on my YouTube channel? And maybe that's a problem. But you shouldn't have a problem, Andrew.
All right, so somebody can just forward that channel to me, please, or the link.
So just
in the group.
Right, in the group. So what you do is just click on the thing and you'll see, so I just have one YouTube channel and you'll see quite a number of recordings. So you'll see Calculus 1 that I'm teaching this semester. You'll see CAPE Integrated Mathematics that I'm also teaching and Precalculus. So what I've done is to label the different recordings so that you don't have to, and I only started labeling the recordings since the summer semester when I recognized that I'm going to have quite a number of these recordings. So what you can do is just, and label also the semester. So scroll through from semester 1, the first Precalculus, and just go through. So you don't have to listen to the recordings to find out which one belongs to you. Just look at the one that says Precalculus, MATH1201, Precalculus, semester 1, 2021. And there are several of those recordings. So just go to the recordings and you should be good to go. Any questions at all you have regarding the recording, drop it in the group. I would prefer if you don't drop it as a private message to me because sometimes I don't have many of your numbers saved to my phone. Space is an issue. So when you drop it in the when you drop it in the chat, I can see that you're trying to get my attention, support and so on, because I actually do make it a point of my duty to look at the chat. I may not always comment, but I take it my point of responsibility to look at the chat, the WhatsApp messages. So drop your questions in the WhatsApp messages. If it's a question that the other classmates don't know how to answer, I'll most definitely go through those. Remember also that the semester has been extended. I'm still trying to go and finish off, so it is that I can do a nice review come January. Your mid-semester is kind of due, but I'm giving Tajay enough time. Well, let me not say Tajay alone. All of you enough time to digest the information. The mid-semester is going to be on indices and logarithms, on indices and, well, coursework 1 is going to be on indices and logarithms. And I'm going to ask that you make sure you go through and master those. I gave one mid-semester to my Calculus 1 group, and most of the students did very well on it, and I'm very proud of it. When I'm giving you your mid-semester, your cameras will need to be on. All right? I'm helping to reduce the amount of collaboration that takes place in these assessments. We are aware of those, and I have put things in place in my class. My class was one students had their cameras on, so I know that the work that they did was a reflection of their abilities. It will be the same thing for you. So the day when I'm giving the mid-semester, I would love and I'd appreciate if you're at work that you ask for an hour or hour and a half just to be alone to do the mid-semester. It's going to be very important that is done. All right. All right. So I'll take my leave of absence for you if there are no other questions, and then I will send off the notes, and as soon as the recording becomes available, I'll send that off as well. All right.
Okay, sir. Thanks.
Bless up. Take care.